Alright, in this video I'm going to talk about another application of graphs, which is related to networking. So as this example, I am going to give the example of the internet as a big network and a big graph. Now, it's too big to look at this point, but it's much easier to understand when we look back at what the internet looked like when it was originally created. So originally the internet was kind of, I guess, blossomed from this network of computers called ARPANET in the 1970s, where a bunch of research institutions connected computers together in order to be able to share information more easily among collaborators. And so you can see that here we have even University of Illinois showing up on the early version of the internet called ARPANET. And what I'm going to do is I'm going to show a little bit about how the network of the internet is itself a graph and how it looks maybe a little bit different than what you might imagine. I'm going to start by talking a little bit about how information is shared on a network like the internet, or how it could be, using something called packet switching. So let's say that we wanted to send the message I love UIC across the network. So we're going to start over here on the right side of the network, and we're going to pass along the message. It's passed in packets, so you can see that as it's passing through the different nodes in the graph, the message is divided up. And obviously a message like I love UIC would not be divided up because it's very short. But the idea is that it's splitting up the data that it's sending across the network in packets. And the packets are numbered. And so once the packet arrives to the destination, so it's arrived across, then the computer that sent it needs to know that it was received. So an acknowledgement is sent back for each packet, and once the sender receives acknowledgement of all packets, then it knows that the message was received. This idea of sending packets is done so that if something is lost along the way, you don't have to resend everything, you can just resend whatever was lost. So for example, if you're sending the 3 packets along, and then here in Utah you lose packet 2, which is the middle part of the message, what happens is that once 1 and 3 arrive at the destination, the acknowledgements come back, so the sender learns that the middle packet wasn't received or wasn't received yet, and has a chance to resend it and complete the message. So this is, and then the acknowledgement is sent back, and now you know that the full message was received. As you can imagine, in addition to losing a packet, you can also lose an acknowledgement. So here's an example of sending the message. It's received, and then the acknowledgement is sent back. Utah again loses the acknowledgement, so we continue forward, and the second and third packet acknowledgements are received. As far as the sender is concerned, they just are seeing this as though the first packet is not received, and so it's going to resend it, and the acknowledgement is going to be sent back again. So that's the basic idea of how information is transported along the graph. Just to give like a really big overview, a really oversimplification of networking and the graph that is used to implement it. So let's talk a little bit more about this graph. So, the internet is just a big connection of computers, right? A big connection of internet connected computers. And so if you wanted to connect your computer to a computer in Australia, for example, if you wanted to visit an Australian website via the internet, then it would need to walk through a bunch of other connections in order to get there. There isn't a direct connection between your computer and every other thing you want to connect to, right? So there's this big graph that connects them all. So the way that it works, or the way that it can work, is that the destination computer has a name and an IP address. I'll talk a little bit more about IP addresses in a second if you're just curious. And so maybe the name of the computer is the name of the website or the server that is hosting that website, and the IP address is that unique number that identifies that computer. Each router on the network is continually passing around information. And one of the ways it does this is it is able to keep track of how close it is to any other router on the network. So for example, if we look at router C here, router C has something called a routing table, and the routing table will store each router in the network that it connects to close enough, and how many hops away it is, as an example. And so each router knows its neighbors and has a copy of its neighbors' routing tables. So B, for example, would have the following tables. It would have the tables for A, C, and D. So if B wanted to connect to F, it would have to connect through its neighbor and report, and then it would report its shortest path to F. So which router would it choose? So it would look at all of its neighbors' routing tables, and it would pick the one that has the shortest number of hops. And so, for example, F is 1 hop. D is 1 hop away from F, so having access to these routing tables is a way that it is able to kind of navigate through the graph. So this is a really a really big picture look at how networking works and how it is a graph and how the information is stored. So graphs, although we're learning it in a data structures class and learning how they're implemented, they look very different depending on the application and the way that the data is stored. So it's very much problem specific. So I mentioned IP addresses, and I showed the IP address IPv4, which each octet is a byte. Turns out that we're running out of IP4 addresses. So total number of computers that can be represented on the internet this way is about 4 billion. Some of these, some things are going to have different addresses if they're on private networks or they're not accessible directly on the web. But either way, we are running out of addresses, and so the internet is transitioning and has transitioned to IPv6, which allows for 18 quintillion individually addressable computers. So that would allow 25 billion devices per person, which should be good. So if you want to see the network graph of the internet, one cool exercise to do is to call traceroute on your computer via your terminal. Here's an example of me running it from my computer. Basically what I've done here is I've picked an Australian university, which is hosted on an Australian computer. And so it's a nice way to kind of see how many different router nodes it goes through in order to actually get to the location that you're looking for. And so here it goes through 21 different routers in order to get to the final destination of that website, which is located here. So that's kind of a fun exercise that you can do to trace route different websites or servers that you have access to and kind of see the graph in real life. And then you can also see all of the routes that actually travel underwater as well, which is fun. And then here's a website to show you where all of those are. especially for any of you who are international right now, maybe you can relate to this very strongly since you're so constantly accessing internet websites that are in the US and you aren't. Okay, so that's it for this. I hope this was a fun introduction, very, very introduction to networking and how graphs relate to it.